So today in this video we'll be working on another very interesting project, that is we'll be creating a heart disease predictor. So we'll be training our model using machine learning algorithms, and then we'll be creating this beautiful looking dashboard using Streamlit, and we'll be running our prediction live. Okay, so yes, last video was about the diabetes prediction system. So yes, today we are here with another medical related model, that is a heart disease predictor. So before we begin building, let me just test my model. So I've got some values from the data sets I have used. So let me enter those values. So yes, if I run my prediction, so you can see here it shows high risk of heart disease, and it shows heart disease risk as 91.47%. So if I use another value, like let me change the values. Then thalassemia as reversible defect. So if I run my prediction, it shows low risk of heart disease, and it shows the risk percentage as 23.31%. So yes, this is a beautiful dashboard made using Streamlit. So we'll be learning to make this dashboard, as well as we'll be training our model, and at last again we'll be running this prediction. So yes, let's get started with the code. So here I have created a folder named as heart disease prediction using machine learning. So inside that folder I have created a virtual machine, and inside that folder I have kept my data set named as data.csv. So now what I will do is I'll create a file named as heart disease prediction underscore machine learning. I'll keep this as ipynb file. Okay. So yes, now let me start my coding. So first of all, what I'll do is I'll import all the required dependencies. So first of all, I'll import numpy as np, then I'll import pandas as pd, then from Scikit-Learn dot model selection I'll import the train test split. Again from Scikit-Learn dot linear model I'll be importing the logistic regression. Yes, and then again from Scikit-Learn dot metrics I'll be importing the accuracy score. The last thing is I'll import the pickle to export this model. Okay, so let me run this. So yes, our dependencies are imported. Now what I will do is I'll load my data set. So I'll name a variable called data, and I'll call out the pandas function, pandas library, and I'll call out the read csv. Then I'll enter my data set name, that is data.csv. So let me run this. So let me check the head of my data set. So yes, this is my data set. So it has various columns like age, sex, CP, trace BPS, cholesterol, FBS, and target. This is the last column that we'll be using to evaluate. Okay, so before we start our model training, we need to do certain pre-processing. Okay, so let us begin the pre-processing of our data set. So first of all, what I'll do is I'll check the shape of my data set. Okay, so yes, my data set has 303 rows and 14 columns. Now next thing I'm gonna do is I'll get some info about my data set. So yes, my data set has 13 integer values, 1 floating values. So yes, these are some common infos of my data set. Now what I'm gonna do is I'll check if there are any null values or not in my data set. So what I'll do is I'll call the isNull function. I'll call the data.isNull, and I'll take the sum. So yes, yeah, you can see here we don't have any null values in any of the columns, so it's a good thing for us in this data set. Our data set is clean. Now let me get some statistical measure of my data set, right? So I'll call data.describe. So yes, you can see the mean of each column, you can see the minimum value, maximum value, And so these are some statistical data sets, statistical info about my data. So last thing I'm gonna do is what I'll do is I'll take the target column, the last column of my data set. Yeah, it's the target column, and then I'll do the value counts. Okay, so I'll group them according to the value. So you can see here 1 means the people who have heart disease and 0 means who do not have. So you know the number of patients with heart disease and non-heart disease are almost equal here. So our data set is balanced, kind of balanced. It's so that it's a good news for us. Our model is not going to be biased. Okay, so yes, now what we can do is now we'll split our data set into X and Y. So in X, what I will do is I'll take my data set, I'll take every column and keep it in the X except one column, that is the target column. So I'll drop my target column and I'll pass the axis as 1. And similarly, I will store only the target column in Y. Okay, so yes, my data set is splitted into X and Y. Now I will split my data set into training data and testing data. So for that I'll create 4 variable, that is X train, X test, then Y train and Y test. Okay, and I'll call out the function train test split, and inside that I'll pass the input as X, Y, I'll pass the test size as 0.2, and I'll pass the random state as 2. Yes, I'll pass the random state as 2 and I'll run this. So yes, our data set is splitted into training data and testing data. Now let me check the shape of my data set. So first I'll check my original data set shape, then I'll get the shape of my training data, and then lastly I'll get the shape of my testing data. Okay, so yes, our original X variable had 303 rows and 13 columns. It is split it into training data and testing data, where training data gets 242 rows and testing data gets 61 rows. Okay, so yes, our data is splitted. Now we can move to the model training part. So I'll create a variable name as model and I'll call out the algorithm, that is logistic regression. Okay, so yes, our model is set. A logistic regression is called out in the model variable. What I will do is I'll feed my X train and Y train. Okay, so I'll call model.feed. I'll type X train and Y train. Okay, now if I run this, so yes, our model is fitted. Our data set is fitted into the model. Okay, now let's make a prediction through this model, and let's check the accuracy of our model. Okay, so I'll create a variable name as xtrain prediction, and I'll call out my model and then I'll call predict. I'll pass xtrain inside this. Now what I will do is I'll create another variable name as training accuracy. Okay, and then I'll call out the accuracy score, and then I'll pass there the X train prediction and the actual value, that is Y train. Okay, and the last thing is that's it. And let me print the training accuracy. Okay, training accuracy. So if I run this, you can see here my training accuracy is 83.05%. okay, so if we see our data set had 303 rows and 14 columns, so it is not a big data set, it is a small data set, but even then our accuracy is 83%, so it's a good, our model is trained good. Okay, because in such small data sets you cannot get high accuracy like 99% or 99.8, but yeah, as compared to the data set, our prediction is going very well, so our model is working perfectly fine. So now let's do one thing, let's do prediction of our testing data also. Okay, so I've created a variable called xtest and I'll call out my model and I'll call predict. I'll pass inside here the xtest. So I'll do the same thing. I'll create another variable, testing accuracy. Then I'll call out the accuracy score. I'll pass x test spread, and then I'll pass the initial value, that is x test. Okay, now what I will do is I'll print my testing accuracy. So print my testing accuracy. So if I run this, see, now our testing accuracy is too good. Our testing accuracy has given 90.16%. So yes, our model is working perfectly fine. Now next step, what we'll do is we'll create a predictive system, okay, and we'll do the prediction here. So let me create a variable called input data, and let me open my data set. So yes, let me take any value. Let me take this value from here. Let me copy this and I'll put this inside this input data. Now what I need to do is I'll convert my input data into numpy array, okay. So I'll create another variable that is np data, and I'll call out my numpy library, and I'll call out the function as array, and I'll pass inside the input data. Okay, so now our data set is converted into a numpy array. Now what I need to do, another thing is I have to reshape my data. So I'll make another variable named as data reshaped, and I'll call out the np data, and I'll call the function reshape, pass the parameter as 1, -1. So now let's do prediction. Okay, so I'll make another variable prediction, and I'll call out my model, and I'll type predict model.predict, and I'll pass inside the data that I have reshaped. Okay, now what we'll do is now let's put in condition. So if prediction yes, so if prediction is 1, we will print you may have the disease, okay, and else if the prediction is 0, you will print here you are less likely to have the disease. Okay, so that's it. Now before we run this, you can check here the values I've taken. Target is 1, that means these are the medical inputs of a patient who has the heart disease. Okay, so if I run this, so it shows you may have the disease. That means our model is working perfectly fine. Now let's take another value of a person who does not have any disease. So let me take this one. I'll copy this, I'll go here, I will paste it here, and then again if I run this, so here you can see in the data set it is the data of a patient who is a non-disease patient. So you can see here it is written you are less likely to have the disease. So yes, our model is working perfectly fine. Now the last thing we need to do is we'll export our model. Okay, so I'll call out my pickle, then I'll call out the dump, I'll pass inside model, and I'll pass the open, and inside open I'll name my model as model.pkl, and I'll give it a write byte. Okay, a write byte. So yes, if I run this, you can see here a file is created named as model.pkl. This means our model is exported, and now we can move further in designing our dashboard. Okay, so yeah, let's design the dashboard using Streamlit and learn and let's connect our model with the dashboard. So let's begin. So yes, now let's begin designing our dashboard. So now what I will do is I'll create a new file named as app.py. Okay, so this is my file created. So now I'll import some libraries here. So first of all, I'll import Streamlit as st, then I will import my pickle, then I'll import numpy as np. That's it. This is what I'll import. Now what I will do is I'll import my model that I had exported. So I'll call out my pickle, then I will call the load, then I'll pass the open, and inside that I'll give the name of my model, that is model.pkl, and this time I'll be giving it a read byte. Okay, so this will enable us to load our model. Now let's call out our Streamlit function, then let's set the page config, and I'll give my page title as let me give it a hard disease predictor. Yes, that's enough. And I'll pass the layout as wide. I'll give the layout as wide. Okay. So yes, now next step I need to do is I'll set my title. We'll do the styling later on. Before that, let's set the title. So now I'll call the st and I'll call the markdown. Inside that I'll be creating a div. Okay, so yes, so let me create a div with a class name. With the class name, I'll pass the class name as big title. So I'll pass the class name as big title. I'll close my div. I'll pass the text, that is hard disease. Yeah, it's predictor. Yeah, hard disease predictor. Then let me close my div. Okay. Now what I will do here is I'll call the unsafe allow HTML and pass it as true. I'll copy this same. Okay, I'll copy this same and I'll paste it here. Okay, so I've created another markdown. Now I'll give it the div class as subtitle. Okay, subtitle, and I'll write here AI powered medical risk detection system. Yeah, this will be better. And I'll pass the unsafe allow HTML as true. Okay, that's fine. Now let's create a st.write and I'll keep it empty. Okay, now what we'll do is let's create 3 columns. Okay, column 1, column 2 and column 3. Now what I'll do is I'll call out the column function columns and I'll pass it as 3, st.column. Yes, now with column 1. Okay, now let's begin with column 1. In column 1 we'll have age. So age I'll call st, yes, I'll call out the Streamlit, then we'll give it as number input. We'll write the placeholder as age and we'll give the range from 1 to 120. That's enough for age. Now next we'll be having a sex. So this time we'll give it as select box. Inside this select box we'll give the placeholder as gender and we'll create a list where I'll pass 2 parameters, that is male and female. Yes, male and female. Okay, that's it. Second will be sex, third will be CP. Now these are some medical terms, so yes, I also do not know too much about it. Yes, but I have searched it on net and CP refers to chest pain type. Okay, so we'll give the placeholder as chest pain type. Yes, chest pain type, and I'll create another list here. Inside this we'll have various parameters. First is typical angina, yes, and second will be atypical angina, yes, atypical angina, and third will be non-enginal pain, and the last one will be asymptomatic. Yes, asymptomatic. Okay, that's it. Now we'll create another variable name as trust bps, and here I will call out the number input. So yes, st.number input, and we'll give the placeholder as resting blood pressure. Okay, this is for column 1. Now let's move to column 2. Yes, so inside column 2 what we'll be having is first variable is call means cholesterol. So I'll call here the number input and pass the placeholder as cholesterol. Okay, TERO. Yes, I did a typing mistake, so yes. Now the second thing in second column will be FBS. Okay, so we'll give it a select box. These are certain medical parameters that we do not know much, but yes, if you browse on the internet you will get full detail about it. So FBS refers to fast blood sugar and it's greater than 120. Okay, so I'll pass a list inside this. There will be two parameters. First is no and second will be yes. Okay, now third thing in the second column is rest ECG. So again I'll create a select box. Yes, st.select box. I'll pass the placeholder as rest ECG. Then there will be a list. First parameter will be normal, second will be ST abnormality. Yes, third parameter will be left ventricular hypertrophy. Okay, now the last thing in the second column will be thalac, and this will be a number input, and I'll pass the placeholder as maximum heart rate. Okay, now the last is the third column remaining. So let me go to with column 3. Yes, now we'll have more parameters here. So first will be exang. So we'll create another select box here. I'll pass the name as exercise induced angina. Yes, induced angina, and there will be a list with first parameter as no and the second one will be yes. Okay, now another is old peak, then I'll call the st.number input. Inside that we'll be having the holder as st depression. Now we'll create the slope variable. Inside that again there will be a select box. I'll pass the placeholder as simply as slope. I'll create a list, and the first parameter will be up sloping, second will be flat, and the third will be down sloping. That's it. Now another parameter is CA, and we'll create another select box, placeholder as measure measure vessels, and there will be another list that will contain the first parameter 0, second will be 1, third will be 2, and the third will be 2, and the fourth one will be 3. Okay, now the last parameter will be tel. So we'll create another select box. Inside that there will be parameter, the name as thalassemia, and the list will contain the first parameter as normal, second will be fixed defect, and the third one will be reversible defect. Okay, so we are done with our columns. Now I'll create a markdown, st.markdown, and inside this I'll close the div and I will pass the unsafe allow HTML as true. Okay, so yeah, we are done with this separating of the columns. What we are gonna do is now we'll convert our values. Okay, now we'll we'll convert the values. So first of all we'll go for sex, give the sex equals 1 if sex equal to male. So if the sex is male, then it will be 1, else it will be 0. We are done for sex. Now we'll go for CP. Now cp.map, I'll create a dictionary. We need to equal it. I'll create a dictionary. So inside that we'll pass first is typical angina, and then we'll give it 0. Second is atypical angina, we'll give it as 1. Third will be non-anginal pain. Yes, non-anginal pain, it can be given as 2. And the last one will be asymptomatic, and it will be given as 3. Okay, we are done with CP. Now we'll equate it the initial CP. So yes, so we are done with CP. Now let's move to FBS. Okay, we'll pass it 1 if FBS if FBS equal to yes, else it will be 0. Okay, FBS, we are done with the FBS. Now we'll go to rest ECG underscore map, we'll map it, and then in this dictionary we'll pass the first parameter, that is normal. We'll assign normal to 0. Then we will move to the second parameter, that is ST abnormality, and we'll assign it 1. Then the last one is the left ventricular hypertrophy, and we'll assign it as 2. Okay, that's it, we are done with the rest ECG. Now what we'll do is we'll assign it again back to the initial one, equal to rest ECG map, and inside this list we'll pass the rest ECG. Yes, so we are done with the rest ECG part. Now what has remained here is the exing. Okay, exing. So now let's move to exing. Very sorry for this. So we'll keep this 1, and if xing equals to yes. Okay, yes, else we'll keep it as 0. Now we'll define the slope. So first is upsloping, and we'll give it as 0. Second is flat. Yes, second is the flat, we'll be giving it 1. The third is the downsloping, and we'll give it as 2. So we are done with sloping also. Let's assign it. Slope underscore map, and inside this list we'll pass the slope. Yes. Now the CA part. So CA will not do anything much, we'll just convert it into integer. Yes, that's it. And the last thing is thalamus. So we'll map this also, and map the thalamus also. First parameter is normal, so we'll assign it as 1. Second is the second parameter is the fixed defect, we'll assign it as 2. And the third and the final is the reversible defect, and we'll assign it as 3. So that's it, we are done with the assigning part. Let me define this to initial. So thal will be equal to thal map, and inside this list there will be thal. Okay, that's it, we have defined it. Now what I will do is I'll call the st.write and I'll keep it empty. I'll do it another one more time. Let me keep it empty. Yes. Now we'll create the predictive system. Okay, so now what I will do is I'll call if button, and I'll name the button as predict heart disease. Okay, so if the user presses the button, it will get into, I'll create a variable name as input data, and I will convert it into numpy array. I'll pass 2 lists, and I'll pass the parameters, that is age, sex, CP, then there is stressed BPS, then there is cholesterol, then there is FBS, then there is rest ECG, we have thalac, we have xing, we have old peak, then we have the slope. Yes, we have the slope, we have the CA, and the last one we have is thalamus. Okay, so that's it, we have imported all the parameters inside the input data. Now what do we need to do is we'll just predict. Okay, so I'll create a variable name as prediction, I'll call the model, and I'll call predict, and I'll pass the input data. So that's it, this is the prediction model. Now another thing what we need to do is sorry, my keyboard is showing some error. So yes, yeah, so now what we'll do is we'll find the probability of the heart disease risk. So I'll create another if here, and I'll call the if haster, and inside this I'll pass the model, then I'll pass the predict proba. Okay, I'll pass the predict proba. Now I'll create a variable name as prob, and inside this I'll create model dot predict proba, model dot predict proba, and inside this I'll pass the input data, and here it will be 0 and then 1. Okay, now I'll create another variable name as risk percent. Risk percent will be round, it will be round, and I will pass the parameters probe into 100 and 2. Okay, now let's create an else. We'll keep the risk percent equals 50. Now let me create an st.write. Let me keep it empty. Now I'll create another if. Okay, I'll create an if prediction. We'll be creating the condition that if the prediction will be equal to 1, if the prediction is equal to 1, then we'll show an error. We'll call out the Streamlit function and we'll show the error. I'll pass the forwarded string here. I'll write the text as high risk of heart disease. Okay, and we'll show the progress, st.progress. Then we'll take the parameter as risk percent and we'll divide it by 100. Okay, and I'll pass the matrix. And inside this we'll pass heart. Yeah, just a second. So heart disease risk. Then I'll pass the forwarded string, and inside that we'll be passing the risk percent. Okay, yeah. So now let's create an else will show a success success. Then we'll pass the low risk. We'll write the text as low risk of heart disease. Okay, low risk of heart disease. And we'll show again the progress. We'll take the risk percentage as the parameter and divide it by 100. And the last thing is we'll take the matrix and we'll pass the input as risk percentage. I'll pass the forwarded string, and inside that in curly braces I'll get the risk percent, and that is percentage. So yeah, this is our basic code of our dashboard, which is almost completed. But the last thing left here is we need to design our dashboard a little bit. So this is the basic rule. Overall designing is done, but we need a little more designing here. Okay, so yes, let me design this dashboard a little bit. Let me use some CSS here. Okay, so now let's do a little bit of styling to our dashboard. So yeah, just below the set page config, I'll call out the Streamlit, then I'll create a markdown. Inside that I'll pass the double quotation. So yes, inside this double quotation I'll be doing my styling. Yeah, create some more. So let me call out my style here. Now what I will do is I'll take .st_app. Okay, so inside this, now what I will do is I'll set my background color. I'll set my background as linear gradient. And I'll pass the parameters 135 degree. I'll pass 3 colors. First one will be hashtag 0f2027. Second will be hashtag 203A43. Third will be hash 2C5364. So I have kept written all these values. So yes, second thing we'll be doing is we'll design the div that I have given the class name as big title. Okay, so I'll call out this div and I'll pass the styling. Okay, So now what we'll do is we'll give the font size as 70px. Next what I will do is I'll give the font weight as 800, and the text align will be center, and the last thing will be color. So I'll give the color as white. Okay, so yeah, that's it for the big title. Now let's take another div, that is the subtitle. So I'll write dot subtitle. So what styling we'll do in the subtitle is we'll create the text align. We'll give the text align, that is center. We'll give the text align as center. Then the next is we'll give the font size. Font size will be 22px. Next I'll give the color. Keep the color, and I have selected a color that is has D1. Yes, D1. Okay, and the last thing here is margin. We'll give a margin of bottom. We'll give the margin bottom of 30px. Okay, so that's it for the subtitle. Now the next thing we'll be designing is the button. Okay, so we'll go st button, then button. Okay, so in this button I'll give the width. I'll give the width as 100%. Next I'll give the height as 60 pixels. Third, I'll shade the font size with the font size as 20 pixels. Then I'll give the font weight as what I'll do is, let me give it just bold. Okay, I'll give the font weight as bold. I'll give the background as has ff 4b. Okay, there's a color selected preset, and then I'll set the color as white. The last thing is I'll give the border radius of 12px. Okay, so this is a very simple styling. So this is not as complicated, very simple styling that I have given here to make my dashboard look little more premium and beautiful. So I'll close my style, and after this what I will do is I'll pass the unsafe allow HTML as true. Okay, so that's it. Our designing and dashboard is completed. Now let me save this, and I'll open my terminal. What I will do is I'll run my file. Okay, so my file name is app.py, so I will type here streamlit run app.py. Okay, so we have an error. Let me just go here. Okay, so it's in 49. Okay, what's the error? Okay, so here s is missing. So let me save this. I'll cancel this. I'll clear this all, and let me run it again. Run app.py. Okay, so here you can see here our dashboard is beautiful, looking very beautiful. So let me run the prediction once again. I'll go to my data set. I'll take any value. Let me take any random value. Okay, let me just take this one. So age is 50, 51, 2. So this will be 50. This is 1. This is 2. Okay, this is 2. And 140. We have the blood pressure as 140, we have the cholesterol as 233, and we have 0 and 1, this is 0 and this is 1, yes, and we have 163. Then after that we have 0 and 0 0.6, 0 and then 0 0.6, and 1, 1 and 3. So this will be 1, 1, and this will go as 3. So what we have here, target as 0, this means it is a non-disease patient. So let me predict. So yeah, I have done some value error, I guess. Okay, so let me take this one, 6313. Yeah, you know, sometimes error may come because our model has very less data set, right? So our accuracy is around 83 to 85%. So it is approximately good data set, but yeah, it is not a perfect data set. You cannot completely rely on this model because it is just an AI predictive model. You need to go to the doctor, you have to see all the things. Okay, so now let me predict this one. I have done some error here. So I'll give the age as 63, male, and then this will be 3. Okay, 3. We have 145, 233, 145, 233, 1 and 0, 1, and this will be 0, 150, and we have 0, 150 again, we have 0 here. Yes, so we have 0 here, we have 2.3, we have 2.3, we have 0, 0 and 1. Okay, so this will be 0, 0 and 1 will be this one. Okay, so now you can see here it is target is 1, that means it is the data set of a disease patient. Let me run this. Okay, so it is showing high risk of heart disease, and the heart disease risk is 77.75%. so yeah, you can use various values here and check the model. And again, let me tell you, this is not a 100% accurate model. To make models like 100% accuracy, you need a very big data set, and yeah, completely perfect data set. So yeah, we had very small data set, and our approximate accuracy was around 83 to 85%. That's good enough for this small data set. And yeah, most of the cases our model is predicting correct, but 1 or 2 cases maybe and the model may predict wrong. Okay, so you cannot completely rely on the model. You have to go to an expert, you have to see to a doctor about the disease. So that's it for this video. We have created a beautiful dashboard for a model called heart disease prediction system. We have used the model as logistic regression. So yes, thank you for watching this video. See you in the next video. We'll be coming with such interesting project in the next video. Thank you.